Hello, welcome to lesson 2B on conditional statements. In this lesson, we're going to learn how to write conditional statements, identify the hypothesis and conclusion, and determine the truth value of a conditional statement and refute false statements with counterexamples. So first of all, what is a counterexample? Well, a counterexample is an example that proves a statement to be false. So, for example, if my conditional statement is, if a shape is a quadrilateral, then it is a rectangle, a good counterexample would actually be trapezoids, because a trapezoid is a quadrilateral that is not also a rectangle. So notice it satisfies the first piece of this, it is a quadrilateral, but it breaks the second piece, it is a rectangle. That's a good counterexample. So try me. If an animal has 2 arms and it is human, guys, go ahead and take a second on your own and answer this question. My counterexample was that a chimpanzee has 2 arms but is not human. There are many ways that you could answer this. All you need is one counterexample to prove a conditional statement to be false. So any 4-legged piece of furniture is a table. Well, there are lots of 4-legged furnitures that aren't a table. I said, as a conditional, first thing I want to do is I want to rewrite this as a conditional statement, that a conditional statement is an if-then statement. So to rewrite any 4-legged piece of furniture is a table, I would write it as if a piece of furniture has 4 legs, then it is a table. Notice I've got the word if, I've got the word then, and I've made it make grammatical sense. So if I have to change the ordering of my words in order to make this work, I will. But the idea is you're starting with it being a piece of furniture with 4 legs and you're ending with it being a table. Now a good counterexample would be a chair, because a chair has 4 legs but isn't a table. So let's move right along. I want you guys to try this one. All books teach arithmetic. First, change it into a conditional statement and then give me a counterexample. So my conditional statement was, if an item is a book, then it teaches arithmetic. Again, I had to add some words in here to make this make sense. Some people write, if it is a book, then it teaches arithmetic. That makes me a little uncomfortable because it is such a wishy-washy word, but if an item is a book, then it teaches arithmetic. There are a lot of counterexamples here. I said Harry Potter does not teach arithmetic, but happens to be a book. That was my counterexample. There could have been a myriad of other things that you would have chosen. So now I want you guys to take a minute and write your own conditional statement with counterexample. So go ahead and give me a false conditional statement and your own counterexample. All right, moving right along. So when do we say a statement is true? A statement is true if it is true for all instances and situations. And a statement is false if it's true for only one instance or situation. So that is why all it takes is one counterexample to disprove a conditional statement. So now let's consider the following statements and decide whether they are true or false. We're actually going to do them together. I know it says do them on your own, but we're going to do them together. So my first example is this. It is 4 times x minus 3 equals 4x minus 12. Well, using the distributive property in Algebra 1, you learn that that is in fact a true statement. Now, bulls have horns. Well, that's false because bulls are not born with horns, but there are other reasons why it's false. Sometimes bulls lose their horns. Some bulls never have horns in the first place. Dallas is in Texas. Well, that is a false statement because there actually is a Dallas, Georgia. But you're very lucky to live here instead, aren't you? Whales live in oceans is a false statement because I can think of some whales that live in aquariums. Cats are amphibians is patently false because cats are in fact mammals and never amphibians. A conditional statement has a hypothesis and a conclusion. The following statement is an example of a conditional statement. If I am tired, then I will go to sleep. I want us in this to underline the hypothesis and circle the conclusion. The hypothesis is the part after the if, I am tired. And the conclusion is the part after the then, I will go to sleep. So we actually use shorthand to designate our hypothesis and the conclusion. We use P to represent the hypothesis and Q for the conclusion, where P is I am tired and Q is I will go to sleep. So to write the above sentence in shorthand, we would write P arrow Q. And what this means is if P, then Q. Or sometimes you'll hear it as P implies Q. Because conditional statements are if statements, we cannot draw a conclusion unless if the if portion of the sentence is fulfilled or if the conclusion is negated. So let's look at some examples of that. If I'm given that if a groundhog shows its shadow, then the weather will be bad. Well, if I know that the groundhog shows its shadow, the groundhog saw its shadow, we can conclude that the weather will be bad. By the way, guys, we're assuming that this given is a true statement. Whereas if I know that the groundhog didn't see its shadow, we can't draw any conclusion at all because I don't have any information about what happens if the groundhog saw its shadow. We don't know if it's going to be good weather, bad weather, neutral weather. We have no clue. The weather will be bad. We also cannot draw a conclusion because we only have information if the groundhog saw its shadow. It could be that when the groundhog doesn't see its shadow, the weather's still bad. Maybe the groundhog has no magical powers over the weather when it sees its shadow. The weather will be good. Now we actually can draw a conclusion because if I know that the weather was good, there's no way that the groundhog saw its shadow because if it sees its shadow, then there was bad weather. So if it was good weather, the groundhog didn't see its shadow. So, moving right along. Let's use information here in the scenarios below to draw some appropriate conclusions. Every time a batter reaches first base, the next batter hits a double. Every time the batter hits a double, the runner on first base scores. John reaches first base. What can you deduce about John? Well, this is one of those chain reaction examples again, where John reaches first base, therefore the next batter hits a double, therefore the runner scores on first base, so we can conclude that John will score. When the sun shines, the grass grows. When the grass grows, it needs to be cut. The sun shines. What can you conclude about the grass? Well, again, it's another chain reaction. We can conclude that the grass will need to be cut. Jim is a barber. Everybody who gets his hair cut by Jim gets a good haircut. Austin got a good haircut. What can you conclude about Austin? We actually can't conclude anything about Austin because Jim is not necessarily the only person in town who gives a good haircut. We just know that Jim is a barber who gives good haircuts. Austin could have gone to another good barber, so we can draw no conclusion here. All dogs are mammals. All mammals are vertebrates. Shaggy is a dog. What can we conclude about Shaggy? Well, Shaggy is a mammal and a vertebrate because if Shaggy is a dog, all dogs are mammals. All mammals are vertebrates. Complete the pattern. 1, 2, 4. Well, it appears that we're doubling each time, so my next two are 8 and 16. Guys, this is an example of inductive reasoning because it's completing a pattern. All right, and then now one last question, friends. Why is the following an example of faulty reasoning? Khaki pants are comfortable. Comfortable pants are expensive. Adrian's pants are not khaki pants. Deduction, and Adrian's pants are not expensive. The only thing we have information about is whether are khaki pants, and we conclude that Adrian does not have khaki pants. So we actually don't have any information regarding pants that are not khaki pants, so we cannot draw any conclusions regarding Adrian's non-khaki pants. All right, guys, that is the end of lesson 2B. Thank you very much, and y'all go take a look at the MML for me. Thank you.